Welcome back. Check these elements. This scarlet rockwool cube used when we grow seeds. When seeds generate first structures, we put little plants into net cups, net pots. This again. These scarlet hydroton balls. These float rafts. These polystyrene. In different systems we can use different materials. Okay, continue readings. Why hydroponics is not just chemistry, chapter 4. Section 2. Understanding hydroponics and how plants grow. Okay. Many people are of the opinion that hydroponics is all chemistry and said the plants grow by this technique are inorganic, which is not true. Hydroponics is not specialized laboratory chemistry. Okay. Some basic high school level chemistry will help one understand how to prepare nutrient formulations. But even without such a background, one can easily learn the procedures. Preparing nutrient solutions can also be done by purchasing ready-made nutrient mixtures. As far as the plants are concerned, they require the same essential elements, regardless of whether they are obtained from hydroponics sources or by natural breakdown in the soil. The advantage of hydroponics is that one can provide the plants with optimum levels of each of the essential elements through the nutrient solution formulation. When growing in soil, these same nutrients are added by the application of fertilizers and compost. However, because of the heterogeneity of the soil, it is more difficult to apply the nutrients at levels that are optimum for plant growth. Okay, let's check figure 4.2 and 4.3. Use of scales for weighing and adding nutrients to a nutrient tank, and then pumps flow these nutrients to roots, and plants get nutrients and generate his structures. Okay, the waste. Check this. A gardener spreading fertilizers on the soil in his garden. Fertilizers or nutrients, special molecules, they roll to the soil. The nature and properties of the soil determine the availability of nutrients to plants. Different types of soils, such as sand, sandy loam, loam and clay, are determined by their percentages of natural inorganic particle sizes and organic matter. Let's check to the soils. This chapter. Clay soil, sandy soil, silty soil, pretty soil, chalky soil, loamy soil. Sand, silt, clay, loam. Different types of the soil, such as sandy loam. This can be sandy soil, loamy soil. Sandy loam, loam, the mix of sand, silt, clay, and organic matter creates ideal gardening conditions. There's different types mixed. Alright, loam and clay are determined by their percentages of natural inorganic particle sizes and organic matter. In traditional garden, we combine different soils, I don't know, and get environment for seed and plant where organics, microorganisms can help plants to live, and nutrient solutions can be different. All right. Sandy soil composed of large mineral particles permits water and nutrients to move quickly throughout it and past the root zone of plants. These are not ideal for vegetable growing unless large amounts of water and fertilizers are supplied regularly. Pure indigenous volcanic sand, in fact, is suitable as a hydroponic medium where oxygen to plants' roots is readily available. At the other extreme is clayey soil that consists mainly of small particles that hold together, tightly retaining water and minerals. This type of soil often has excess water with poor drainage, causing a lack of oxygen to plant roots. At the other extreme is clayey soil. Clayey soil is it like this? That consists mainly of small particles that hold together, tightly retaining water and minerals. This type of soil often has excess water. See, where consists mainly of small particles. This type of soil often has excess water with poor drainage, causing lack of oxygen to plant roots. With this poor aeration, plants also suffer from lack of mineral uptake. Alright, loamy soil, like that. A loamy soil has a good mixture of large and small minerals, plus organic matter, humus. What is humus? Okay, first, organic matter derives from plants, animals, and microorganisms. In forests, for example, leaf litter, woody materials fall in the forest floor, blah blah blah. Humus, snow-living, finely divided organic matter in soil derived from microbial decomposition of plant and animal substances. Humus, which ranges in color from brown to black, consists of about 6% of carbon, 6% nitrogen, and smaller amounts of phosphorus and sulfur. As humus decomposes, its components are charged into forms usable by plants. Alright. In classical soil science, humus is a dark organic matter in soil that is formed by decomposition of plant microbial and animal matter. It is kind of soil organic matter with distinct properties due to its high surface area. It is rich in nutrients and retains moisture in the soil. Okay, other words. Humus, that is microorganisms, plants, little animals that die and decomposed into components in the desert soil. He did decompose into nutrients that plants can be used. How I understand in the current date. Let's continue. A loamy soil has a good mixture of large and small minerals plus organic matter, humus, which provides adequate minerals, water, and oxygen to the plants. Minerals, water, and oxygen. Maintaining soils in this optimum state of structure and fertility is often challenging, requiring soil tests and frequent additions of fertilizers and compost of adequate quantities for plant growth. With hydroponics, the choice of substrate depends on the availability, costs, crop, water retention, oxidation, structural integrity, and sterility. For most backyard gardeners, the availability and cost of the substrate are not restrictive because they use relatively small amounts. Some crops grow better in more pronous substrates, whereas others grow well where there is higher water retention. However, oxidation is important to all plants, so drainage is critical, especially for long-term crops such as tomatoes, peppers, eggplants, cucumbers, and other vine crops. Some short-term crops, such as herbs, basil, mint, and watercress, and lettuce can grow in water. Culture systems. Structural integrity, the availability of the substrate to retain its structure and not break down during the growth of the plants, is basic to hydroponic growing. Let's check what means oxidation. I think oxygen get by roots by plant. Water retention can be means that roots get water and this used for generating leaves, organs like sugar storage, tomatoes. We're reading water retention. I don't know what means. Let's check. I make pause. Oxidation in hydroponics is critical for plant health, as it allows roots to perform respiration and absorb nutrients effectively. Methods to ensure adequate oxygen levels include using air pumps with air stones, creating air gaps, and employing automatic siphoning systems. This is used in hydroponics systems. How I know? Oh yes, like this image. We use nutrients We mix in a tank, use pump to flow into the roots of plants. We use light and some things. Cubes. Water retention. Clay pebbles, cocoa care, rockwool, perlite, vermiculite. Interesting. Retention or water retention. This word refers to the ability to hold onto or keep something over a period of time. In various contexts, it can have specific meanings. In hydroponics, it describes how well a growing medium can hold water and nutrients for plant uptake. Water retention is a critical factor in hydroponics, influencing plant health, nutrient uptake, and overall yield. Here's an overview of how it works and what to consider in hydroponic systems. Importance of water retention. Nutrient delivery. Water is a medium through which nutrients are delivered to plants. Proper water retention ensures that nutrients remain available for absorption. Root health. Adequate water retention aids in maintaining moist conditions around the roots, preventing stress that can occur from dehydration. Oxygen availability. While water retention is vital, it is also essential to ensure that some air can reach the roots to avoid root rot. Oversaturation can lead to anaerobic conditions. Methods to improve water retention. Growing medium. Different mediums have varying water retention capabilities. Rockwool. Good water retention, but requires careful management to avoid oversaturation. Cacao coir. This is that materials that we check it. Elements. Rockwool cube. Hydron bells prevent water retention. I don't know. Perlite, while it retains some water, it also provides good aeration. These materials give oxygen for plants. Water frequency. Adjusting the frequency of watering helps in managing how much water is retained. Automated systems can optimize this based on real-time moisture levels. Humidity control. Maintaining optimal humidity levels in the growing environment can assist in preventing excess evaporation and improving overall water availability. Nutrient formulation. This type nutrients used can influence water retention. Some fertilizer types can help retain moisture in the growing medium. Overwatering. Use a drainage system to prevent roots from sitting in water. Underwatering. Monitor moisture levels and adjust watering schedules. Nutrient leaching. Use more concentrated nutrient solutions, but ensure they are balanced. Root rot. Provides adequate aeration and avoids waterlogged conditions. Okay, continue it. Okay, with hydroponics, the choice of substrate depends on the availability, cost, crop, water retention, oxidation, structural integrity, and sterility. For most backyard gardeners, the availability and cost of the substrate are not restrictive because they use relatively small amounts. Some crops grow better in more pronounced substrates, whereas others grow well where there is higher water retention. However, oxidation is important to all plants, so drainage is critical especially for long-term crops such as tomatoes, peppers, eggplants, cucumbers, and other vine crops. Some short-term crops such as herbs, basil, mint, and watercress, and lettuce can grow in water culture systems. Structural integrity, the ability of the substrate to retain its structure and not break down during the growth of the plants, is basic to hydroponic growing. How I understand structural integrity means we use substrate that not breaks structures of plants. Plant cells, I think, can be broken if we use big or very small components, substances, nutrient solutions, I mean. This quality and sterility are of prime importance in the selection of a medium. If a substrate is not free of pests and disease organisms, they will attack the plant's roots, causing decreased plant vigor and yields. Organisms can break structures of plants, like roots and leaves, and some things. Alright, you will then be in a similar situation as what often occurs with soil growing. All of the variable properties of soils that can restrict plant growth, the road lack of oxygen and mineral availability, and or occurrence of structural breakdown, and the presence of pests and diseases are difficult to control. With hydroponics, you choose the best substrate that provides optimum levels of oxygen, minerals, and water. In addition, most of the pests and disease factors in a soil-less substrate are avoided. We can add fertilizers in traditional growing, and this can too break down our plants. In hydroponics, we can avoid this if we control levels of minerals, oxygen, and water. Overall, hydroponics and soil growing are not different with regard to the needs of the plants. Okay, the chemistry behind hydroponics is not different from soil growing with regard to providing ideal levels of nutrients to the plants. Only the procedures and some sources of nutrients differ. Procedures and sources different in traditional and hydroponic systems. With soil, we like to use slow-release compounds that will not rapidly pass beyond the roots of the plants, whereas in hydroponics, we want highly soluble compounds that will dissolve completely in water because the nutrient solution is applied directly to the plant roots. The chemistry is the same for the plants as they must actively take up the same nutrients and water from the soil solution of the soil. What? The chemistry is the same for the plants as they must actively take up the same nutrients and water from the soil solution of the soil, or from the nutrient solution in hydroponic culture. Other words, nutrients in the soil get by plants, and in hydroponics, nutrients get by from water, and the needs of plants is not different. In traditional and hydroponics, we use in hydroponics directly nutrient solutions. This means water plus molecules that plants needed, or minerals like calcium dioxide and other. We speak about this later. Okay. The principal difference between soil and hydroponic cultivation. Cultivation means we grow our plants and its nutrients, water, oxygen, and plant generate his structures, generate his storages. The storages means vegetables, leaves, and other eatable parts. We get these parts in eating and something. Okay. The principal difference between soil and hydroponic cultivation is this precise management of the availability of the essential elements to the plant roots under hydroponics. The other techniques in the care of the above the ground portion of the plants are similar in both hydroponic and soil cultures. What? The other techniques in the care of the above the ground partitions of the plants are similar in both hydroponic and soil cultures. Okay, I not understand what this means. I just continue. All aspects of plant training, pest and disease control, even watering by a drip irrigation system, also apply to soil culture. What means irrigation system? Let's check. See this: pump, flow, nutrient solution, and this pot into tank. Cycle system. Oh, hydrant pulse. Plant and net pot. Or not net pot. Okay. Oh, not irrigation, drip irrigation system. Okay. One step further is to extend your growing season by the control of environmental factors such as temperature, light, carbon dioxide, and relative humidity throughout greenhouse growing. You may grow either soil or soil-less in the greenhouse, but normally it is advantageous to use hydroponics under controlled environments to maximize the use and yields of your plants. All aspects of plants training, pest and disease control, even watering by drip irrigation system also apply to soil culture. One step further is to extend your growing season by the control of environmental factors. We need control factors such as temperature, light, carbon dioxide, I think in nutrient solution, humidity, how much water molecules in air in a greenhouse. In other words, this means you may grow either soil or soil-less in the greenhouse, but normally it's advantageous to use hydroponics under controlled environments to maximize the use and yields of your plants. Okay guys, in the next video we continue reading Hydroponics for the Home Grower, Chapter 5, Plant Growth, the Environment and its Effects on Plants. This image molecules. I ask what this means. ChatGPT, because I not understand. Molecules. Okay. By